Okay. I had a couple questions on this for your response, so I'm just going to do a quick review of A and B here. So if I'm finding g of 2, I'm putting a 2 in here. I'm actually going to write this up here. So g of 2 means x is 2, so my integral would go from 1 to 2 of my function. So this is finding the area between 1 and 2. So it's the area under the curve, or in this case, above the curve, between the curve and the x-axis. So it's this triangle right here. So the area of a triangle is 1/2 base times height. The base of this triangle is 1. The height of this triangle, it looks like 1/2. It is 1/2. If you write an equation for this line, the slope is -1 minus 0. That's your rise. Over your run, 2 minus 1, or 3 minus 1 is 2. So that's your slope. So the equation of this line, if I use this point, I'm going to use that point because y is 0. So it's going to be y equals -1/2 x minus 1. And if I put in a 2 in here, because I'm trying to find out the y value when x is 2, if I put a 2 in here, I get 2 minus 1, which is 1, times -1/2. So this point is over 2 down -1/2. Sorry, I had to close the door there. My children were making sounds. So the height of this triangle is 1/2 because I went down 1/2. So 1/2 base times height. And this is nice that this is -1/2. This is exactly why area under the curve ends up to be negative. So this would be -1/4 for g of 2. Now g of -2 is going to be from 1 to -2 of f. Okay, now when we have our integrals, we like the lower bound to be the smaller number. So I want to flip these upper and lower bounds. And when I do that, remember I need to put a negative out front. So I'm still finding the area between -2 and 1, but then I'm going to take the negative of it. So the area between -2, here's -2, and 1 is this triangle and this half circle. Okay, so I'm going to say this is going to be negative. This triangle is above the x-axis, so it's going to be a positive area. And it's got a height of 3 and a base of 1. So it's going to be 1/2 3 times 1, or just half of 3, or just 3/2. The area of this half circle is going to be pi r squared divided by 2 because it's a half circle. R is 1, so it's just going to be pi over 2. This is below the x-axis, this area, so that's going to be negative area. So the circle is negative area, the triangle is positive area, but we're taking the negative of all of it, so we're going to end up with -3/2 plus pi over 2. Okay, because we flip the upper and lower bound, so we put that negative out front. Okay, now let's look at part B. The scoring rubric, I think I typed this wrong. This was supposed to be g prime of -3. So think if I take the derivative here, oops, sorry about that. If I take the derivative of this, I'm going to have g prime of x. If I take the derivative of the left side, if I take the derivative of the right side, I'm taking the derivative of my integral, or I'm taking the derivative of the antiderivative. So remember, when you take the derivative of the antiderivative, you just get the function out. So g prime of x is just f of x, your function. So if I'm finding g prime of -3, that's going to be f of -3. F of -3, ooh, where's -3? Ah, it's this point right here, which, yeah, I'm going to call that 2. Yeah, I think that's going to be 2. So g prime of -3 is the same as f of -3, which is going to be 2. Now g double prime, so if g prime is f of x, then g double prime is first derivative of f. So if they're asking for the first derivative of f at -3, they're asking for the slope of this line. Because derivative is slope. Because this is a line, I can just calculate that. So slope of this line is going to be y minus y, 3 minus 1, which would be 2. That's my rise. And my run is -2 minus -4. So that'd be -2 plus 4. So that'd be 2. So that's 1. So g double prime is the same as f single prime is 1.